So what I'm gonna go over right now is over lab number 9, which is on metabolism, which you don't need to know, which I'm just gonna tell you the basics of what you need to know, and then you can further study through it yourself. And yes, this is what we're just gonna go over. So the first thing that you kind of need to know is the term mole. The definition of a mole is pretty much term referring to a given number of molecules of a substance, and that's pretty much that. Um, 1 mole of ATP, or one key thing is that 1 mole of ATP equals 7 kilocalories, or oops, that says 1/700. It should be 7,000, not 700 calories. So 7,000 calories of energy. The definition of calorie is raising 1 gram of water 1 degree Celsius, while a kilocalorie is raising 1 gram of water 1,000 degrees Celsius. Okay. One process that you have learned in this lab was beta oxidation, which was the process in which you are breaking fatty acid chains into 2 carbon fragments. So like you have, for example, you have this carbon chain right here. Okay. So what happens is that you're breaking these into pairs, and so you break it there, and you break it there. You broke it twice. So then each time you break the carbon bond, you are producing a net ATP of 4. So you're producing a net of 4 ATPs. So you're producing 3 carbon bonds, but you're breaking it twice. So like you have 3 carbon bonds, you're breaking the chain twice. Okay, so you would make a total of 8 ATPs in this case. And what would happen is that these two carbon fragments would then be processed into acetyl-CoA, which would then enter the citric acid cycle. So one little thing that you need to know is that in your lab homework, there was a specific section in which there was a matching. There were some matching exercises that you had to do. Make sure to know and memorize those terms. There's terms like glycogenesis and anaerobic and aerobic, and you definitely need to know those terms. So it's provided on your sheets, and that should be it for that. I'm going to go over the aerobic respiration for glucose. So the basics is that 1 NADH equals 3 ATP, while 1 FADH2 equals 2 ATP. So that's the basics of what you need to know. So the first process that you go through is through glycolysis. And through glycolysis, what happens is that you have to, you're breaking glycolysis into 2 molecules. So that when you're producing it to 2 molecules, what happens is that you're producing 2 ATP and 2 NADH total for those 2 cycles of glycolysis. In addition, you are losing 2 ATP because you have to use 2 ATP to begin the process of glycolysis. So as a result, when you have 2 ATP and you have 2 NADH, which in exception to the rule, this produces 2 ATP since NADH would turn into FADH, since this is actually in the cytoplasm, it's not in the actual mitochondria. So what would happen is that NADH would produce, in this case, 2 ATP. So you have 4 ATP plus 4 ATP again for glycolysis, and then minus 2, you would have a total of 6 ATP. Next is the citric acid cycle. And the citric acid cycle, in total you would create 24 ATP, and you have to do this, you have to go through the cycle twice because you have 2 molecules that are entering through as a result of glucose going in. So naturally for one cycle of citric acid cycle, you are producing 3 NADH, 1 FADH2, and 1 ATP. But since we're going through this process twice, we're going through the Krebs cycle, or aka citric acid cycle, twice, you will now be producing 6 NADH, 2 FADH2, and 2 ATP. And so as a result, your 6 NADH, each one would produce 3 ATP total, like 3 ATP for each NADH. Your FADH, each one would produce 2 ATP per FADH, and you would produce an overall of 2 ATP just generally from the citric acid cycle. And as a total, you would produce 24 ATP. Now, between the process of glycolysis and CAC, you are what's happening is that you are producing 2 NADH, and when you're producing 2 NADH, that is then converted into into ATP. So as you remember, one NADH equals 3 ATP. So since you have 2 of them, you would produce 6 ATP. So if you add the 3 processes, the ones through glycolysis, the one through citric acid cycle, and the one between the two, you would have an overall of 36 ATP per 1 mole of glucose. Now, now we're gonna go over proteins, carbohydrates, and lipids, and dealing with the digestion and dealing with the metabolism of those of those specific types of substances. So, as kind of like the role, kind of like the conversion point, is that proteins produce 4 kilocalories per gram, carbohydrates produces 4 kilocalories per gram as well, while lipids or fats are produced 9 kilocalories per gram. So I've given like an example of what would an example of a problem that you could do. So in this case, we have 4 grams of protein, you have 6 grams of carbs, and you have 5 grams of fat. So when you're converting this into kilocalories, you would multiply your 4 grams of protein by the 4 kilocalories per gram of protein, and that would equal 16 kilocalories total. Then if you have 6 grams of carbs, times it by the 4 kilocalories per 1 gram of carbohydrates, you would create 24 kilocalories. While for 5 grams of fat, you would multiply that by 9 kilocalories per 1 gram of fat, and as a result, you would have 45 kilocalories. Now, if you're trying to add all of these together, if the question is asking for the total amount of kilocalories for these 3 substances together, you would, if you add the 16, the 24, and the 45 kilocalories all together, you would have 85 kilocalories.